Okay, now we continue to learn Chapter 1, Matrices and Systems of Equations. Section 3, Matrix Algebra. We will learn Part 3, Transpose of a Matrix and Symmetric Matrix. First, the transpose of a matrix. The transpose of an n by n matrix A is the n by n matrix B, denoted by A subscript T, defined by B ji equals aij for j varies from 1 to n and I varies from 1 to n. So for the transpose matrix B, its ij entry just equals a ji entry of the matrix A. So we can also see that the jth row of A transpose has the same entries as the jth column of A. Just in matrix A, you write the column, and in A transpose, you write it as a row vector. Okay, and similarly, the ith column of A transpose has the same entries as the ith row of A. Algebraic rules for transpose we can write as A transpose then do transpose equals A itself. And the first rule. The second rule is alpha times A transpose equals alpha times A transpose. And the third rule is A plus B transpose equals A transpose plus B transpose. And the fourth rule is the multiplication of A and B, then do the transpose equals B transpose times A transpose. Here, we only emphasize the last one. You should always keep in mind that AB transpose for the multiplication, then do transpose equals the transpose you do first. However, you change the order of the matrix. So it's equals B transpose times A transpose. Okay. So the definition of transpose and for the operations of addition, matrix multiplication, and scalar multiplication will help you to do the proof. So we just omit it here. It's not difficult to do it. We do some exercise first. Given you A and B, all are 3 by 3 matrices, and ask you to compute AB transpose and B transpose times A transpose. So you can do it by yourself. And later you can check it is really true that AB transpose equals B transpose times A transpose. Okay, and you can also do exercise on page 56. Okay, now we see an application for this matrix algebra. The first one is about information retrieval. Our database now consists of these book titles. So B1, book 1, the title is Applied Linear Algebra. B2 is Elementary Linear Algebra, and B3, Elementary Linear Algebra with Applications. And B4, Linear Algebra and its applications, like this. And B7, Matrix Theory. Okay, and in information retrieval, you want to search some book, so you will write some keywords. You will type some keywords on the computer, and you want it give you some recommendations, right? And in order to do this, we first consider the collection of keywords, which is given by the following alphabetical list. So we have keywords, algebra, application, elementary, linear matrix theory. Okay, we have those keywords. And then we consider about the 7 books we have, the title. Okay, so you can have this table. So this table means, for example, book 1. Book 1, the name is Applied Linear Algebra. So for such words, if it appears, you will write 1 here. Applied, so application, you think it equals, okay? So application also you write 1, linear, so 1, algebra 1 here. So other keywords, they do not appear, so you just write 0 here. Similarly, for other books, for example, B7 is matrix theory, right? For B7, you only have these 2 entries to be 1, all the other entries 0, okay? And then if the words we are searching for are applied, linear, and algebra, then the database matrix and the search vector are given here. First, you have this matrix. These matrices are just come from that table, right? B1, B2, B3 till B7. Okay, and X here, X is what you search applied linear algebra. So these three positions are 1, all the other position 0. So which books you will recommend to the searcher? Okay, so this can be done by this matrix multiplication. You can use y equals A transpose times x. Here you use a transpose of a matrix, and you also use a matrix multiplication. Okay, so use this A transpose times this vector. You will get a score here, a score vector here. So you'd better to recommend the first book, and the third book, the fourth book, and the fifth book, because they appear the keywords more keywords than other books. Okay. And now we consider another concept, which is symmetric matrix. So an n by n matrix, a square matrix, okay, A is said to be symmetric if A transpose equals A. Let us see some examples. The first one, this is in fact a diagonal matrix. Of course, this one is symmetric. Yeah. How about the second one? This is a 3 by 3 matrix, and along this main diagonal entries, so you will see they are symmetric to each other, right? So this is also a symmetric matrix. How about this one? Is this a symmetric matrix? The answer is yes, right? Because it is true that its transpose equals itself.